Calculus people, welcome back. Buckle your seatbelts today because we're going to be in motion. We're going to be doing position, velocity, and acceleration functions, both in an applied capacity and in table problems. Number one, a particle moves along the x-axis so that anytime t greater than or equal to 0, the position is given by this fellow here, t cubed minus 9/2 t squared minus 12t plus 5. A, at t equals 0, determine whether the particle is moving to the left or to the right and explain how you know. Well, that information is all going to live in the derivative. So if we take the derivative of x, you get x prime, which is the same thing as velocity. And it's really good to write that down as you go, both to keep track for your own mind and also to communicate to the reader that x prime of t is the velocity function. And we get 3t squared minus 9t minus 12. At time t equals 0, we just have to plug in a 0, and we get v of 0 equals negative 12. So what does that mean? The particle is moving to the left because v of 0 is negative. Part B, at what time or times does the particle change directions? It's going to change directions when the velocity function equals 0. Now we just have to solve for t. So we can knock out a 3 and then factor that function, okay? And we get two t's, t equals negative 1 and t equals 4. T can't equal negative 1 because it says only for t greater than or equal to 0. So t equals 4 is where we think the particle changes directions. But the problem asks us to justify our answer. So how do you do that? We'll plug in values to the right and left of t equals 4. So I make myself a little number line, and we already know that v of 0 is negative 12. So to the left of 4 is a negative velocity. To the right of 4, if you plug in v of 5, you get 18. So that's a positive velocity. So that's what we'll use to justify our answer. At t equals 4, v of t changes from negative to positive. Part C, at t equals 1, is the velocity of the particle increasing or decreasing? So now we're talking about the rate of the velocity. If it's the rate of the velocity, that means it's the derivative of velocity, or acceleration, which is 6t minus 9, and we're curious about t equals 1. So a of 1 is negative 3. Therefore, the particle's velocity is decreasing at t equals 1 because a of 1 is negative. Part D, still at t equals 1, is the speed of the particle increasing or decreasing? This is a little bit different. Part C asks if the velocity was increasing or decreasing. Part D asks if the speed is increasing or decreasing. What's the difference? D is asking, is it speeding up or slowing down? At this point, we need to compare the sign of the velocity to the sign of the acceleration. So we already know at 1, the acceleration is negative 3. The velocity at 1 is negative 18. Those have the same sign. They're both negative. So since the acceleration at 1 is negative and the velocity at 1 is negative, the particle's speed is increasing at t equals 1. Part E, what is the particle's acceleration at t equals 1/4? And then explain the meaning of your answer in terms of the particle's velocity. So first, we need to plug in 1/4 into the acceleration function. And it says that the acceleration is negative 15 over 2 units per time squared. Well, what does that mean? That means the velocity is decreasing because the acceleration at 1/4 is negative. Moving on now into a table problem. The table below gives the velocity in feet per second of a particle moving along a horizontal axis. V of t is a twice differentiable function of time. So just to be clear, this table is all about velocity. At time t equals 0, determine whether the particle is moving to the right or to the left, and explain how you know. At time t equals 0, the velocity is negative 4, which is less than 0. Therefore, the particle is moving to the left at a rate of 4 feet per second. Part B, is there any time or times during the interval between 0 and 15 seconds when the particle is at rest? And of course, we need to justify. How do we figure that out? It's asking, is the velocity ever 0? Look at the table. Can you find a spot where the velocity might be 0? None of these velocity values are 0. But what we know is that v of t is differentiable, therefore it's continuous. So can we find a spot where 0 is between two of those values? So between 2 and 3 seconds, the velocity goes from negative to positive. Therefore, there is a time between 2 and 3 seconds that the particle is at rest. Part C. Use the data from the table to find an approximation for v prime of 8. V prime of 8, that's the derivative of velocity, which is the slope. Explain the meaning of that in terms of particle motion. So we need the slope at 8. Well, 8 really isn't one of our time hacks, but we know that 8 is between 7 and 10. So we're going to use these points to find the slope. 5 minus 3 over 10 minus 7 gives us a slope of 2 over 3. And that tells us that the particle's velocity is increasing at that rate. Part D has a lot going on, so pay attention. Let a of t equal v prime of t. Is there a time guaranteed such that a of c equals 0 sometime between 0 and 15 seconds? Is the acceleration ever 0? And of course, we're going to justify our answer. A function must be shown to be continuous in order for a value that's not shown to be guaranteed. So how do we know that a of t is continuous? The problem tells us that v of t is twice differentiable, and that's really important because if you start with velocity and you take the first derivative, you get acceleration. It says it's twice differentiable, which means we can take the derivative of acceleration. Well, if acceleration is differentiable, that means it's also continuous. So we can say because v of t is twice differentiable, we know that a of t is continuous. Okay, we've just set up the fact that we can do the problem. Now, is there ever a time that acceleration is 0? If we have the numbers of velocity, we can see that from 0 to 10 seconds, the velocity is increasing. You know what that means? The graph has a positive slope. So let's write that down. We'll say between v of 10 and v of 7, we can find that the slope is 2/3, which is greater than 0. Then after 10, the velocity starts decreasing. The slope is negative. So we use 2 points to find that between v12 and v10, we have a slope of -1. That's less than 0. Therefore, the acceleration has to be 0, sometime between 7 and 12 seconds. We know that because of the intermediate value theorem. There was so much in that problem. I hope it made sense to you. Example 3. This is a calculator question, so go dig your calculator out of your bag if you would, please. An object moves along the x-axis for a time 0 to 6. The velocity at any time is given by the natural log of t minus 0.15 t cubed plus the quantity t squared plus 2t to the 4/5. That's why it's a calculator question. At t equals 4, is the object speeding up or slowing down? The cool thing about this is you can just graph it. And if you graph it, and you can kind of see right there is time t equals 4, you can see that the velocity is above the x-axis, okay? But the acceleration or the slope is negative there. So because the slope is negative, the acceleration is negative, and the velocity is positive above the x-axis, those are opposite signs, so the object is slowing down at t equals 4. Part B, at what time does the particle change directions? You could set velocity equal to 0, but just use that graph and trace the zeros. So you'll find t equals 0.390 and 5.007. Now you always have to justify it. So at 0.390, velocity changes from negative to positive. That's right here. The graph goes from below the x-axis to above the x-axis. Or you could say the object changes directions from left to right. At 5, it goes from above the x-axis to below the x-axis. So then it's moving from right to left. Example 4, another calculator question. A particle moves along the x-axis so that at any time, t greater than or equal to 0, its velocity is given in meters per second by that crazy function there, 4 plus 2.3 sine of 0.85 t. Okay. Find the acceleration of the particle at t equals 4 and the direction. If it's a calculator question, how can you use the calculator to do most of the work? First of all, we're going to keep track of what we know. V prime of t equals the acceleration. Now, go into the equation editor of your calculator and type in that velocity equation. Then hit Math 8 and have the calculator find the derivative at a point. So this is the acceleration at x equals 4. A of 4 equals negative 1.890. What is the direction of the particle? Direction is determined by velocity. So again, have the calculator do the work for you. Have it evaluate that equation at 4. The velocity at 4 is 3.4122, so the particle is moving to the right. Here we have another object moving along a line between time 0 and pi. Its position is given by negative 3 sine 0.25 t squared plus 1. What is the velocity of the object when the acceleration is 0? Wow. So we want to know the velocity when the acceleration is 0. First, we'll have to take the derivative of our position function. So you'll have to do that by hand. V of t equals negative 1.5 t times cosine 0.25 t squared. Use the chain rule there. Now we need to take the derivative again to find the acceleration. This time we're going to have to use the product rule because we have two functions being multiplied together. So that's what the acceleration looks like. So pause, make sure that makes sense to you, write it down. Now when does that equal 0? In comes the calculator, okay? graph the acceleration function on your calculator. Wow, that's fun. Then trace the zeros. Again, put the acceleration function into the editor, and we know that acceleration is 0 at about 1.6165. Okay, so we found when the acceleration is 0. Now what's the velocity at that time? Again, have your calculator do the heavy lifting. Just plug that into your calculator to get a velocity of negative 1.925, blah, 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 blah. Now we can describe what's happening to the object. The object is moving to the left because velocity is negative. A model rocket is launched vertically from ground level with an initial velocity of 114 feet per second. We have a position function of negative 16t squared plus 114t. So first thing is we would like the velocity and the speed of the rocket at t equals 5 seconds. Velocity and speed. Okay, well, velocity is going to be in the first derivative, negative 32t plus 114, plug in 5, and we get the velocity at 5 is negative 46 feet per second, which means the speed is just the absolute value of that. Is the rocket speeding up or slowing down at t equals 5? Well, now we need to look at acceleration. We need to know the sign of acceleration at time t equals 5. So let's look at the velocity, take the derivative of that, and we have an acceleration of negative 32. Because the velocity at 5 is negative and the acceleration at 5 is negative, we know that the rocket is speeding up. What's the maximum height? Remember, if a rocket goes up and comes back down again, the maximum height here where it turns around is going to have a slope of 0 or a velocity of 0. So let's take the velocity function and set it equal to 0. And then we can solve for t. So at 3.5625 seconds, the rocket will be at its maximum height, which is what? We know when, but how high is it going to go? We'll just plug that into your position function, and we know it gets to about 203 feet. What's the speed of the rocket when it hits the ground? Well, when does it hit the ground? Set the position function equal to 0. Solve for t. It starts at time 0 and hits the ground at 57/8. So we'll plug that 57/8 into our velocity function. Speed is the absolute value at that moment, so 114 feet per second. We covered a lot of ground today, so thanks for hanging in there with me, and I hope to see you back sometime soon.